Hey, so this is going to be about a really brief video about memorizing exact values. So exact values for trig. Values, trig. Okay, so the first thing you'd want to do is remember or memorize um, your trig functions, the graphs of your trig functions. So for example, we'd have in here, we have our sine wave, we have our cosine wave, and we have our tan wave. Okay, so let's just write sine, cos, and tan here, right? And so the second thing we do is this little table that I'm going to show you guys. So let's oops, that was not supposed to happen. Let's focus on defining all our trig functions first, and then we'll come back around to doing this table. So let's start there. Let's switch up so we have a little bit of color in here. Let's start with our sine wave because that's generally where people start. So you have your y and your x-axis as usual, and you get this sort of wave thing. It's pretty basic sort of shape. I think most people feel kind of comfortable with the fact that that's a wave at the very least. So what we have here is 0 degrees, and they kind of go up in 90-degree increments. So you get 90, 180, that's there, sorry. 270 here, and 360, and it's 360 degrees in a wave. We could talk about where that came from as well, maybe, if people are interested. So we get a maximum amplitude, and amplitude is the height or the y value, maximum amplitude of 1, and a minimum amplitude of -1. So just from this graph, we already have a bunch of values. If I was to ask you what sine 0 is, which means if I was to give you an x value of 0, what would the y value be? And you get 0 because you know at an x value of 0, the graph is not above anything. It's right here. It's at the origin. Okay, and so you could also tell me what sine 270 is straight away. And so you'd be like, okay, I'll go to 270 and then I'll go down because that's where the graph is, and I get to -1. So knowing the shape of the graph, you should be able to tell 5 values straight away: 0, 90, 180, 270, and 360, which is very, very neat. Um, Now, mixing in the table there helps us get a little more detail, a little more resolution for other bits of the sine wave. So, um, actually, we won't do that just yet. Let's finish drawing up all the waves, and we'll do the table underneath them. So if we have 2, we have cosine. Now this is very similar. In fact, it's identical in the sense that it's just the sine wave pushed back 90 degrees. So it looks like this, and I wonder if you can see that it's just the sine wave pushed back. And so what we're actually doing is drawing these things from 0 to 360. But if you were to continue, sorry, that should be flat. If you were to continue, it would look like this. And if you were to continue the sine wave, it would look like this. It would continue. So these waves are pretty much the same. It's just that there is a difference in angle. That cosine has been shifted back 90 degrees. Okay, let's put in those little values again. So we have 0 here. I'm going to put that there. There's a 90 here. Sorry about the scaling on this thing. 180 here, 270 here, and 360 here. Also, as well, the wave continues forward, not just backwards. Yeah. Okay, and so from that, you get another 5 values for cosine. So now I should be able to tell me your cosine 180 degrees. And it also ranges from 1 to -1. So you should be able to tell cosine 180, it's just -1. Last but not least, we'll get the tan wave, or tangent wave, considering I've spelt the other ones all the way through. Um, that is not the y-axis. Okay, so there's these funny little things called the asymptote here. We could also talk about where they come from or why they exist. So the tan wave goes up like that, has this thing here. and it does this. So there's a funny little thing about the tan wave is um, its range repeats every 180 degrees. So if you notice, the sine wave repeats every 360 degrees, right? It goes up, down, and then again, next time it'll go up, down for another 360, and then up, down again for another 360. Similarly, the cosine wave goes down, back up, and then it'll do that again, down, back up, and it does that every 360 degrees. Tangent's a little different. It actually does that every 180. So let me just put these numbers in so we don't get them confused. 90, 180 is still here, 270 is still here, and 360 is still here. So it still covers 360 degrees, but really what's repeating is this middle section. This graph actually continues, and it does this over and over and over and over and over again. But we draw it out as a 360-degree wave because the other two are 360-degree waves. Now, why is that helpful? It gives us three values, tan 0, tan 180, and tan 360. So we get 0, 0, 0 every single time for those ones. We don't know tan 90. That's undefined. The graph here never touches this line because this is an asymptote, which means the graph will never touch it. Okay, let's get into some exact values. I'm going to do those in, let's go for dark blue for that. Okay, so I'm going to put down sine, cos, and tan. This is how I do it. There are ways using triangles, which some people find easier to remember. Depends on if you're a visual learner or not. Okay, so these are the exact values we're going to cover. So the first three you do have to memorize. You do have to memorize that sine 30 equals a half. That sine, let's fill them in different values, different colors actually. So we can tell them apart. So sine 30 is a half. Sine 45 is 1 on root 2. And sine 60 is root 3 on 2. Now there's no two ways around this. This is just straight up memory. You can use the triangles to help you remember, but I found that was slower. Spending a little bit of time on memorizing it, kind of like times tables, just made it very, very quick for me to do calculations. The reason I set it up in a table is if you remember this first row, all of the other answers come very easily. So cosine happens to be the reverse of this. It's just this row in reverse. So instead of root 3 on 2 being on the end, it comes to be the first value. This stays in the middle, because if there's three things and you reverse the order of those three things, the middle term will stay in the center. And this half ends up on the end. So it's very easy to remember, given that you've remembered the first row. Now we're going to do something a little interesting with sine and cos to get tan, which is part of the reason, well, the entire reason, that this wave is how it is. So we're going to use the idea that tan theta is equal to sine theta on cos theta. Now, this is an important identity, so whether or not you're trying to memorize this table, you should know it. Given that you know it, it's kind of useful to memorize a table as well. Okay, so we need to use that. So what does that mean? That means if I take this value, so that means sine 30 over cos 30 is tan 30. So if I ever wanted to figure out tan 30, I could just use these two values. Now that looks a little complicated because you have a half over root 3 on 2. Which is a little annoying, but because it's a fraction over fraction. But I like to call these double rainbows because when you have something like a half, I'll use a different color for the middle, all over root 3 on 2, you can do two things. You can do the standard school way, which is to, if you have a fraction on the bottom, you flip and multiply instead. What I like to do is if the denominators of, I call them double rainbows, if the denominators are the same, I just cancel them out. So I get 1 on root 3. Now that's true because of if you flip and multiply, you get the same thing, but it's a little quicker. So what you'll notice is every single one of these denominators, when you do this over this over this, are the same. So here you have 1 on root 2 over 1 on root 2. You don't really need to do it there because we just do anything over it itself is 1. But here it's very useful. If you root 3 on 2 over 1 over 2, cancel the bottom, you just get root 3 on 1, which is just root 3. So it's very, very, very quick. Given you memorize these, the rest of them come easily. Very, very easily. Okay, hopefully that helped you guys. Let me know. I'll see you in the next video.